Okay, so I thought I'd record a video on how to use all the applets and things for these two sample kind of significance tests and confidence intervals, rather than relying on the formulas like Dr. Stevens and Dr. Lowski like to use. You certainly can; they work. They're just more complicated to use than with the single sample tests. So I thought I'd walk you through a couple of examples for each. So. First kind of two sample test we're going to look at is what's called the paired differences. In other words, what you're doing is you're looking at two different samples, but they come from either the same individual or the same, I guess it's the same individual is how the best way to look at it. It's, for example, does taking an SAT prep course improve test scores? So you have a before and after. Does some diet cause weight loss or weight gain, depending on what you're trying to do? And so again, before and after. And usually that's a flag that you've got a paired different situation, is because there's a before and after data, and the data is coming from the same, before and after comes from the same individual. So that's the first thing you want to pay attention to, that when you're looking at these. And these are from the OpenStax textbooks. A couple of things you got to know, you got to have a big enough sample. Well, the first example is only going to have 8 individuals. And that's not a very big sample. So the other thing is does it come from do the differences come from a normal population, a normal distribution? And there's a couple of ways to test it, and I'll show you one. Sometimes you just don't know. So when you run in a test, if you ever had to do this for a company, you'd have to put these conditions. Yeah, this is a pretty small sample, not totally sure it's normal, so on and so forth. But because these are textbooks examples, we're gonna run with it and do it anyways. So we're going to do two things. We're going to do a confidence interval. We're going to do a significance test. So I guess the first thing we should do is let's do the confidence interval. So this is data that came from the OpenStax textbook, and these are trying to investigate the effectiveness of hypnotism in reducing pain. So they gave some kind of evaluation to the patients before hypnotism, and then they gave some evaluation of patients after hypnotism, and now we're going to see was hypnotism effective in reducing these pain levels. This person had an increase, but all the rest of them had a decrease. So what the mistake that people make is they say, oh, well, it looks like most of them decreased. Sure, there's a difference here. Let's go with it. Well, as you know, samples can vary, so you've got to show statistically how it's statistically significant, or there's a statistical difference. So when we do a pair of differences, because of the same individuals, what we do is we find the differences in like before and after. So usually you'll do the second measure first, subtract it from the first measure, because you're trying to say, how's it comparing before and after? And the textbook already did this for us. If they didn't give it to us, you'd have to do this. You'd have to do the subtraction. So now the question I have is this come from, because this is only a sample size of 8. So do these differences come from a normal distribution? So what I did, let me see if I can't find it now. So I went to that QQ plot generator, and I pasted in the differences and had it generate a QQ plot. And that's looking like, aside from that one point, that's pretty well following that trend line. We could make the argument these differences are coming from a normal distribution. So then if we think about that, what I did is I went to the Rossman Chance applets, and that's in, let's see, if I come back to the course, let's come back here to the course modules. This is the short course. If you're seeing this and you're in one of my other stat courses, this is the 7-week course. So I think in both courses I have these online statistical tools. And there's the link to the QQ plot. You used that last week. And then we're going to do this 1 and 2 sample confidence here. Let me get a pointer going here, so maybe it's a little more obvious what I'm pointing to. So this 1 and 2 sample confidence interval and significance test, this applet works fantastic. So I come out here to this theory-based inference, and it'll work for proportions, it'll work for means, it'll work for 2 proportions, 2 means. And so the 2 proportions and 2 means applet will save us so much time. You'll definitely want to use it. So I opened up another instance of this, and I pasted in those differences, and I clicked use data. You can also use the summary statistics. I'm going to show you that before we get done with this problem. And here's a little dot plot of that data. And while this doesn't look too non-normal, you get this outlier here, so something's happening. But we looked at the QQ plot, so it's probably safe to go. And like we said, so this is a textbook situation. So then what you got to worry about is to do the, actually, we don't want to do it. We want to do a confidence interval, didn't we? So let's do a confidence interval change. Make sure you have your level of confidence there. And there's the difference. So this is the 95% confidence interval. The lower bound is negative 5.5 or negative 5.6, and the upper is negative 0.69. So something that I noticed about this is it doesn't contain 0, so I couldn't say the mean difference is 0. That's promising as far as making any decision. But let's interpret what that confidence interval means. And I did that a little bit earlier here. Let's see if I can find what I wrote. Nope, not here, Dan. Where is it here? Yeah, so I said we're 95% confident the true mean reduction in pain levels after hypnotism is between 5.6 and 0.7 points lower. Notice that way, because these are both negative, I was able to say that. If it were one were negative and one were positive, I'd have to say like between as much as 5.6 points lower and 0.7 points higher if that was a positive number. So a lot of it's context. Sometimes it's very awkward to say this correctly. Do the best you can with it. So then how about a confidence interval? I mean, how about a statistical test? So when we do a hypothesis test, you always want to state the claim. Well, the claim for this was right here, right here. So test the claim that the sensory measurements on average are lower after hypnotism. This helps us do a couple things. If I identify the claim first, what that'll allow you to do is it'll allow you to write the two hypotheses in a correct order. Here, let me come back to the summary notes. So there's all these different ways you can write the hypotheses. Null hypothesis is always equal. That's just like last week's with the one sample. Then you get three options: a right-tailed test, a left-tailed test, right-tailed test, and two-tailed test. Because I'm trying to test to see if the pain, it reduces the pain levels, we're looking for a left-tailed test. Notice these are 0. No difference, the mean difference is 0, or no, it's something other than 0, and something going on. So if we go out to that Rossman chance applet, see, I did have it all done on the slide, but I actually want to make sure you know how to use this applet. So I'm going to uncheck my confidence intervals. I'm going to check tested significance. I have my two hypotheses set up here. I'm going to calculate it. It makes a little nice sketch of the situation. That's the p-value area. There's our test statistic. There's our p-value. You want to report out both of those. Report out the t-score or z-score if it's that kind of test, and the p-value. And then we're going to do some decision making. So let me come back here to my applet. I mean, not my applet, but my slideshow or here. So that's that. If you have a graphing calculator, you can use that stat test too. Some of the MyOpen Math exercises have videos where I show you how to use the calculator, but you probably don't have a graphing calculator, so we're going to use this. So let's see. Here's my test statistic page. So there's the screenshot I did. So what does that mean? What are we going to do with that? Well, you got to put it in context. So one thing you can do is use this. This is in that testing helps file that I have out in the week 5 area. And because the claim was it was less than it was, my claim didn't have an equal to. There wasn't an inequality. So I'm going to go this branch. Did I reject HO? Well, I guess I haven't decided that, have I? At the 5% level of significance, this p-value is less than 5%. So I'm going to reject HO. Okay, because that's less than the level of significance. No different from last week. So since I rejected HO, I'm going to use this phrasing to put my decision in context. And this is just how you can start it. This helps you from saying too much, because you don't want to say something that will lead you to getting sued. So the sample data supports the claim that, you see the way I worded that, And then I just paste it in the claim. The sensory measurements on average are lower than average. Okay, and that's the significance test. It's that easy with the applet. The tricky part is deciding on the hypotheses, then getting the data you need, the differences or whatever. What I did earlier is I found the mean and the standard deviation for those differences. That list of differences right here. If you find the mean and the standard deviation, often with significance tests out of textbooks, they'll give you the mean and the standard deviation. What you can do is you can come back to that applet, and instead of using data, remember how I had to paste in the data? It asked me, what's your mean and standard deviation? Of course, it already calculated it from before, but you can type it in right there and then calculate the test statistic and see how you get in the exact same values. So you don't have to use the data every time. You can use summary statistics to get that, which is honestly easier if you ask me. Okay, so that's a significance test and a confidence interval for a paired difference. Now I got one more example we can walk through. I mean, you don't have to watch the rest of this video if you think you're good to go. But here, let's come back here and let's look at this next question. So this is a study, see if diet was effective in lowering cholesterol. So I see a before and after situation with two sets of data coming off of a single subject. So this is a paired difference situation. So the first thing we do is find some differences. I haven't done that yet with this one, and the textbook didn't tell us. So give me a minute here, and you find the differences, and I'll find the differences, and then you can come back and start this video again and see if we agree with that. So this is what I found when I subtracted the after numbers from the before numbers from the after. I've got these numbers. I'm seeing most of them were lower, 2 were higher. So I guess what we need to do now is construct and interpret a 95% confidence interval. Usually 95 is kind of the default. The nice thing about the applet is you can change that level to anything. Marple Math does that. They'll ask you some weird confidence intervals. So I guess why don't you go ahead and paste these numbers into the applet and then see what you come up with, and you come back and see and then try to write the confidence interval. And I'll do that here, and then I'll come back and you can come back and watch a video, see if we agree there. I'm just thinking maybe I should show you how to get the data in here in case somebody's having a hard time with it. So I'm back at that Rossman Chance applet. I've got the old data that I used actually before I had it unpasted and we had the data there. I mean, the summary statistics here. So I'm going to clear the data that's in there, and then I'm going to just paste it in, Control V. I'll use the data, and there's that dot plot. Looks kind of spread out. I guess I want to know whether it's a normal distribution. So I'm going to come back here, and I'm going to select all this data here. I'm going to paste in those numbers. I'm going to compute. And some non-normal behavior, but not ridiculously bad, but certainly looked at worse. So I guess you're probably, and if you think about that dot plot that I saw, I mean, that's kind of uniform, really, kind of spread out. So I guess we're safe to use this procedure on it. So why don't you stop the video and then try to run the confidence interval, and then write a conclusion. That we are 90. So just maybe I should point out what the conclusion is. So when you write these conclusions, remember what I did for the last one was we are 95% confident. I have that somewhere here. Where did I write that? Is it here? Yeah, here. We are blank percent confident the true mean difference, or somehow word that until you're talking about difference, is in between blah and blah. And these numbers will come from the confidence interval from the applet. Remember, low number here, high number here. So go try that, and I'll do it too. Well, let's see here. So I've got those numbers. I want to do a confidence interval. I want a 95% confidence interval. Notice how I had to click calculate CI because it had the old values there. So I'm seeing from negative 19.9 to negative 1.7. Okay. So I found so when I did the applet, I found that let's see, do I still have it right there? Yeah, the applet told me between negative 19.9, say, and negative 1.7. So I worded my conclusions. We're 95% confident that reduced cholesterol levels by as much as 19.9 points to as little as 1.7 points. You could reverse those, and I mean, I guess it's just about phrasing it so it makes sense, and talking about how much you reduce the cholesterol levels. Okay, so that's the confidence interval. Now let's try to do the significance test. Now, remember, we're looking when we do a significance test for a paired difference. It's going to be HO will always be this. Then we get to decide, do we want a left tail test because we're reducing cholesterol levels? Do we want a right tail test because we're reducing cholesterol levels? Or do we have no idea which way it's going and we'll use the two-tailed? So once you start, and then run the test, and then you can come on back and see how I did all this. Okay, so I wrote these. Let's see, let me get a point going. So I wrote these as my HO and HA, again, left-tailed test, same as before, and I ran this test of significance, and I used the same hypotheses I just decided on. There's my test statistic, negative 2.73. There's my p-value of less than 5%. If we're doing a 5% level of significance, we're going to reject HO. So what does that mean in context? Well, the claim was our H1, so that did not, or HA, so that did not contain inequality. Did I reject HO? Yes, I did again. So I'm going to start that phraseology. And as you can see, the sample data supports claim that cholesterol levels on average is lower after the diet. And that's basically the process. I mean, I encourage you to try some exercises out of the textbook, and you can post them in a forum if you want to get some feedback on them, and then I'll have a and then you'll have a proficiency test with I'll have all three kinds of tests in there. This one and the next two I'm gonna record. Okay, so hopefully this helps you.